Okay, I'm back for round 3, you guys. I'm going to start your review. Let's take a look. Let's go with blue. Actually, why don't we pick a color that makes me happy? How about like a really pretty purple? I love purple. Okay. All right. What is this? It's like one of these things is not like the other. All right. We're trying to find one of these polynomials whose end behavior isn't like the others. Okay. Well, they're all positive. So they all 3 of these end going upward. So let's see where they start, okay? If they're odd, they'll start going down because they'd be opposite directions. And if they're even, they'll go the same way. So this is a 1 right here. And there's a 2. So if I add the degrees, when I multiply these through, this is going to be a degree 3. All right? This one right here, 1, 2, 3, 4. This is a degree 4. Okay, so this one starts this way and this one goes this way. So let's see what this guy is. Ooh, he's a 2. So this one's end behavior is not like the others. Okay. Let's see. One of these has different zeros than the others. Okay. Let's go left, right. This one right here, what multiplies to 12 and adds to -7? There's going to be a 4 and a 3 with a -4 and a -3. So this factors into x minus 4 and x minus 3. So 1, 2, 3. These are the factors of this one. This one is exactly the same. Oh, what? There's got to be these. Oh, wait, one of them. Shoot, just kidding. Okay, definitely one of these two is not like the other because I can see these have the same thing going on here. X minus 4, x minus 3. So it doesn't have the x plus 4. So we just got to see what this guy does. That's a x minus 3. And then this is a difference of squares. It's going to factor into x plus 4 and x minus 4. So this one's not like the others. Degree. All right, they're going to try to confuse us. I can see it coming. 2, 2, and 1 makes this guy a degree 5. A 3 and then 2 right there makes this a degree 5. And then a standard form 1. That means just go find the term with the biggest exponent. This is a 7. All right. Okay, number of x-intercepts. Okay. Difference of squares. This is 4, x squared, and 3. So what I just did right now is I identified that this is the difference of squares. So I square rooted everybody. And I know I'm going to have one with a plus and then another one just like it with a minus. And then I can tell, all right, when you have the sum with a square, that's only going to lead to imaginary zeros. This guy right here, though they're not going to be pretty, will give us 2 real zeros because of the minus. Because if I solve it, you guys. If you don't know what I'm saying, solve it. So 4x squared minus 3, set it equal to 0 and solve. 4x squared plus 3, set it equal to 0 and solve. You'll see how down the line you'll end up with the square root of a negative number in this situation. You will not end up with the square root of a negative number in this situation. Now, it'll be a really ugly square root. However, it will be positive, which means it will be real. Okay? This one has 2. Number of x-intercepts, 2. Okay. This one, I mentioned in a previous video how when I look at these, I can tell. It was actually the 312 video. How I can tell if they factor or not. This one does factor. So what you can do is just go to the box, because it factors, and put 2x cubed, negative 3x squared, negative 8x, and positive 12 in, and start taking stuff out. So here you could take out a 2x. Here you can take out a negative 3. Here you can take out an x squared. And here you could take out a negative 4. That means that this guy factors into 2x minus 3 and x squared minus 4. Please go check that video, the previous video, because you can't do it if it doesn't factor. You know what? I can't. I gotta tell you why. Right here, notice how if you were to like split this up and take what you can take out of these two, the GCF, so they both have an x squared. Take the x squared out, you'll get 2x minus 3. And notice here you have a GCF you can take out, and it's a negative 4. You'll be left with 2x minus 3. When what you're left with is the same, that's when it factors. So if you can look at this in your mind, imagine taking the GCFs out and see if they work out like this, then you can either do it this way, or if you've already done all this, now you just take the 2x minus 3 out. And once it's out, you're only left with x squared minus 4. So there you have it. And now, I'm going to get 1 x-intercept out of that one. And I'm going to get 2 x-intercepts out of this one by the same logic as here. So this one has 3. Okay. And then looking at this, I'm not going to do it. Do it if you want, factor it if you want, but I taught you guys some stuff in class, all right? If this is a 4th degree polynomial, then it has 4 zeros, all right? Okay, now, either they are all real, okay, or some are imaginary. Now, I taught you that imaginary zeros, you can never get 1 or 3. You can never get an odd number because they always come in plus or minus pairs, all right? Conjugate pairs. So if there are imaginary zeros, there would be 2 of them, which would then mean that we would have 2 real ones because there's 4 total, all right? And I guess the last scenario is that all 4 are imaginary and there's 0 real ones, okay? But either way, it's either 0, 2, or 4, which means this one with 3 zeros is for sure the odd man out, okay? All right. If you want to solve it, though, go for it. Just taking the opportunity to drop some knowledge on you guys. All right. Let's go sketch. Let's go sketch some graphs. Okay, sketch the graph of each function and then rewrite the equation in standard form. Oh, no, thank you. Okay. Let's go look at a boop, boop. Here's a graph. This guy factors into an x minus 4 and an x minus 2 because to get an 8 and a negative 6, I need a negative 4 and a negative 2. So that means that I've got myself an x-intercept at negative 3. I've got one at 4, and I've got one at 2. And the fact that this is positive means it ends going upward. And then the fact that all these multiplicities are 1 means I just go through these. So this just goes through. Then it needs to come back to go through that. Then it needs to come back to go through that. That's it. All right? They just goes through. Multiplicity 1 means it goes through and does no wiggles. All right? Okay. Oh, and write it in standard form. I think I purposely forgot that. You guys, do the box, I guess. Okay, put x squared, put minus 6x, put 8, put x plus 3, and then just multiply, all right? This is x cubed, 3x squared, minus 6x squared, minus 18x, and then this is 8x, and this is 24. And then combine these like terms that are usually in that diagonal pattern, and you will get that a of x equals x cubed 3x squared minus 6x squared is minus 3x squared. Negative 18x plus 8x is minus 10x plus 24. Okay, let's go look at B. For B, let's investigate here. They're being so mean right now, all right? They're being so mean right now, you guys. Take a look at this negative x. This is just like if there were a negative in the very front of the function, okay? So this function is totally negative, all right? Be on guard for mean tricks like that, okay? Okay. What it means also, in addition to being negative, is that 4 is an x-intercept and negative 3 is an x-intercept. So I go to 1, 2, 3, 4. I go to negative 3. The function being negative means it ends going down. And then the multiplicity of 1 right there means I just go through like a line, okay? Then I have to come and touch this 0. This one has a multiplicity of 2, which means it bounces like a parabola, like that. And there's a potential sketch of that guy. And then now we're going to have to multiply, all right? So you can multiply x plus 3 with x plus 3. Do it, simplify it. It's x squared plus 6x plus 9, all right? And then you can take x squared plus 6x plus 9. See what laziness gets you? And multiply it by 4 minus x. You have 4x squared, negative x cubed, 24x, negative 6x squared, 36, negative 9x. And then this will simplify to go with the biggest exponent first. B of x equals negative x cubed. And then let's combine like terms this way. So 4x squared minus 6x squared is negative 2x squared. 24x minus 9x is a positive 15x. And then plus 36. And now, you guys, I'm actually thinking them telling you to multiply it out and write it in standard form wasn't them being mean. It was them giving you a chance to catch what this negative right here did. Because here you can clearly see that's a negative function. So maybe they were trying to be nice. Write a possible equation. Okay, you guys, this was on the quiz. I told you guys this is like a game of Clue. All right? This ends down. So my first clue number 1, is that it's negative. My next clues are my x-intercepts. So clue number 2 is that I have x-intercepts at negative 3, negative 1, and 2. All right? So what does that mean? That means I've got x plus 3 in the equation. I have x plus 1 in the equation. And I have x minus 2 in the equation. But please know that these little exponents, which are the multiplicities, we do not yet know. All right? That's going to be clue number 3. All right? I figure out what those exponents are by looking right in the small little square vicinity around that 0, okay? If it goes through like a line, that means this little exponent over there is a 1, okay? So at negative 3, it is a 1. If it does a little parabola shape and it bounces, then it's a 2. So right here, that's a 2, or potentially higher. as long as you stay even, all right? But I'm gonna go with 2. I'm not trying to get fancy here. And then finally, just be careful. If they told me what the degree was, I'd have to then pick this number properly to make sure these all added up to that degree. This is another, just a line. Therefore, the exponent here is a 1. All right? It has to be a 1. It cannot be a 3 or a 5, all right? If it's a 3 or a 5, it goes through like this line does, but it does a little wiggle. All right, we're going to see it in just a second. Final answer, you guys. Make sure you don't forget the first clue that it was negative, and then all of this. So this is c of x. I will write that c of x equals negative x plus 3 to the first power. You don't have to write it. X plus 1 to the second power, and then x minus 2 to the first power. Remember, you don't have to write an exponent and a 1, but I would not mark off any points if you did. Okay, let's go over here. And let's play our same clue game again. All right? You guys pause the video, try it on your own, please. Okay? And then come back and see if you got it right. This one ends up. So this one is positive. Clue number 1. D of x equals a positive. Okay? Next, I need my x-intercepts. I've got one at -4. I've got one at 0. And I've got one at 3. That means that I have x plus 4. And then I have x minus 0. And then I have x minus 3. All right? And now my last clue is, what are these exponents? All right? Look right here. This goes through, which indicates an odd multiplicity. But when it goes through with a curve, it can't be a degree. It can't be a 1. So this is a 3 or higher, as long as it's odd. I'm just going to go with 3, though. Right here, it just goes through like a line. No wiggle. So that's a 1. And right here, it does a little bounce like a parabola. So 2. All right. And then here we go. You can leave it like that, but we do really prefer an x minus 0 to be simplified to just x, and we like it to be in the front, and then have these guys follow. Okay, perfect. And remember, I just dropped the 1 because you don't have to write the 1 when 1 is an exponent. Here's a graph of the data from fermenting 1 kilogram of bean waste for 19 days. Okay? What is a reasonable domain for this situation? Okay, remember that domain means x's, and my x's is days. And in this graph, I start from 0 days and go on to 30 days. So I would say that a reasonable domain is between 0. What are the variables? Did they tell me? They didn't give me variables. So let's just call it x. To 30. That's what I think. Okay. Determine whether points A, B, and C are local maximums, local minimums, or neither. You guys, every mountain high is a local max, and every valley low is a local min. So that looks like a mountain high, and then because it does appear to dip a little, so this is like a valley low right here. This is a mountain high right there. And that is absolutely a high. So I would call A and C maxes, local maxes, and I would call B a local min. Interpret what point C means in this situation. Point C means that at about 2, 4, 6, 8, 10, that at about 24 days, we have reached biogas produced in liters, the maximum biogas produced in liters of 2,000 liters. That's what that means. Okay, point C means at 24 days, we reach a max of 2,000 liters of biogas. Okay, you don't have to understand anything about this situation, all right? Just what's X, what's Y, write them down. What do they mean? What do they mean? Boom. Okay, this video is already 21 minutes long. Do we think we can rewrite it as a product of 2 or more factors, determine all the zeros? Okay, let's try it. This first one, difference of squares, okay? I would first factor it into x squared minus 4 and x squared plus 4. Then I would factor the part that's still a difference of squares into x plus 2 and x minus 2. And that one is x squared plus 4 still, because the sum of squares doesn't factor. Okay, then they want all the zeros. Okay, zeros are going to be negative 2, positive 2, and that one, if I set it equal to 0 and solve it, I will get plus or minus 2i. So that's it. Oh man, less work than it seemed. This one, you guys, I got an exponent. I got half that exponent. I got a constant, meaning no variable at all. I'm going to try to factor this with 9 and 3, because 9 and 3 can multiply to negative 27 if the 9's negative, and add to negative 6. So this factors into this, what's in the middle, which is x squared minus 9, and x squared plus 3. This one keeps factoring into x plus 3 and x minus 3 because it's a difference of squares, just like this was, just like this was. And then this one stays. And that means that my zeros are plus or minus 3. That means a negative 3 from here and a positive 3 from here that I shorthanded. And then x squared plus 3, set it equal to 0. I've done it in the past. This is going to get us root 3i. I'll do this one just to give you one. Subtract the 3 from both sides first. So this is how you would do this one as well. Then you square root both sides to get that x squared equals plus or minus, oh sorry, not x squared. So we square rooted both sides. Square cancels. Square root and square cancel. I get x equals, anytime I square root both sides, I get a plus or minus. And then the square root of 3 is not doable. We keep it square root of 3. But the negative will become an I outside of the radical. So that's where that came from. Those are the zeros. I'm getting tired of this purple color. Should we go with a green? Let's look at this. This I'm going to factor, all right? Because I notice that if I divide this up right here, and if I take the GCF out of these two, that's an x squared. If I take the x squared out, I'll get 2x plus 1. And then over here, if I take the GCF, which is positive 4, if I take that out, I get 2x plus 1. And now I have these two. They both have a 2x plus 1. So if I take the 2x plus 1 that they both have out, I'll be left with x squared plus 4. So that's how that one factors, all right? And then now I can get the zeros. This one gets me -1/2. Remember, the opposite of that number is the numerator, that number is the denominator. And then this one from earlier is plus or minus 2i. All right, here we go. Another one. Exponent, half the exponent. Oh, look at this, a sign. I should change my color. I'm going back to purple. And then a constant right here means that I can factor this using the box, all right? I just need to know what multiplies to no, not -3. What multiplies to 4 times -3, so -12, and adds to 11. So that's going to be 12 and -1. So then I'm going to write 4x to the 4th, but then I'm going to rewrite 11x squared as a plus 12x squared and a minus 1x squared minus 3 and factor. So here I take out the x squared. Here I'm going to take out a 3. Here I'll take out a 4x squared. Look at that. You can take a 4 out and you can take x squared out. And over here I'll take out a -1. And this guy factors into x squared plus 3. I think they're being nice. And 4x squared minus 1. Because we already did x squared plus 3 earlier, and it gave us those two zeros. So we have plus or minus radical 3i. And then we have this, which factors into, it's a difference of squares. So it factors into 2x plus 1 and 2x minus 1. That means that the zeros that it gives me are the opposite of that number divided by that number, opposite of that number divided by that number. You could have written this as plus or minus 1/2. Doesn't matter though. Okay. Last one. Oh, not the last one. There's 2 more. You guys, I notice, I want to show you that if I start, there's nothing that's going to make these two match like this one did. I just want your eyes to kind of get used to what you should try to factor and what you should not try to factor, all right? 3x plus 4 is 3x plus 4. Nothing's coming out. And 2 and 9 are not going to turn into 3 and 4. Well, no, they're not, okay? Not in that order anyway. So, okay. But the fact that they gave me a clue is helpful, because I can divide this into this, all right? So take this, put it on the outside, start with the first term in the first box. If a 2x cubed is here and an x is there, then a 2x squared must be there. That's how they would multiply to make that. And 2x squared times -4, that's -8x squared. And then if I have a -8x squared here and I want a -9x squared, then I need another -1x squared, so that these two would add and combine to make that. Okay, since this is the review, I'll give you my trick one more time. You want a -9, subtract how much you have already, so subtract -8, and then simplify it or use your calculator and you'll get -1. That's what you need, okay? Then this is a -x up here, because a -x times an x is a -x squared. -x times -4 is a positive 4x. Now I have a positive 4x, but I only want 3x, so I'm going to take away 1x. So this must be a -1. So then this here must be a 4. And the fact that this matches this means that this divides evenly. This guy is a factor, which shouldn't be a surprise because they told us. It just confirms that we did it right. Okay, that means that this guy is a more manageable polynomial to use to find the rest of the factors. So let's try to factor this since it's quadratic. What can multiply to this times this, which is negative 2, and add to negative 1. Negative 2 and positive 1 will do it. So now we're going to go to the box to factor this time. We're going to put 2x squared in the first box, and we're going to put negative 1 in the last box, and we're going to put negative 2x in one of the boxes, and we're going to put 1x in the other box, and factor. X comes out of here, negative 1 comes out of here, 2x comes out of here, positive 1 comes out of here. So this factors into the x minus 4 they gave us, the 2x plus 1 that we found, and the x minus 1 that we found. And that means that I've got some zeros. There's 1 at positive 4. There's 1 at the opposite of this number divided by that number. And there's 1 at 1. And now the last one here. They give me this guy. They tell me that negative 3 is an x-intercept, which means that x plus 3 is a factor, which means that if I do this, let's see what we get. This should divide nicely. So with the x here and a 3x to the 4th here, then I needed a 3x cubed here. With a 3x cubed here times a 3, that's a 9x cubed. If I have a 9x cubed, but I want a 5x cubed, then I got to take away 4x cubed. Remember, take what you have, subtract what you want. No, wait, that's wrong. Take what you have, take what you want, which is 5, subtract what you have, which is 9, and get what you need, which is a negative 4. So want minus what you have will give you what you need. Okay. In the box, what you need in the box. Negative 4x cubed with the x out there makes this a negative 4x squared. And then this times this is a negative 12x squared. Now, I have a negative 12x squared. I want a negative 3 minus the negative 12 that I have will get me the 9 that I need. So you need to add 9x squared. And then this is a 9x, and then multiply these. This is a 27x. And then if this is a 27x, but I want 15, then I'm going to have to take away 12 of these. So minus 12x. Again, you could take what you want, which is a 15, subtract what you have, which is 27, to get what you need, which is negative 12. And then this is a negative 12, and then a negative 36, which means this is good. And that means that this right here is a more manageable polynomial to use to find the rest of the factors. Okay? And this one actually, I'm noticing, can factor by grouping. Let me show you. It can factor like number 3 did, because it's 3x cubed minus 4x squared plus 9x minus 12. And if I just kind of split it and group it and take the common factor out of here, which is x squared, I'll be left with 3x minus 4. And if I take the common factor out of here, which is 3, I'll be left with 3x minus 4. And then if I take the 3x minus 4 that they have in common out, I'm left with x squared plus 3. And pair that up with the x plus 3 that was originally given, and we can find this right here is this thing factored all the way. I just remembered that's what they asked me to do, yeah. Then now we can get the zeros. So negative 3 is 1. The opposite of that divided by that is another one. And this is the same one that keeps popping up with the plus or minus root 3i, all right? We did it earlier, twice. There's the zeros. Okay, I feel like at 35 minutes I should stop it. But at the same time, this is the last task. But also looks long. Divide, divide. What does it mean? Here's a polynomial. What is it? Yeah, this looks long. I'm gonna stop here. I'm gonna stop.